Hi and welcome to this next video from the number section. And in this video we're going to be looking at fractions, and in particular we're going to be looking at these things called equivalent fractions. So here we go. Let's set off with a bit of pizza, and if we take that pizza, chop it down the middle, there we go. Now we've got two halves of pizza. But if we now cut it again across the middle, going across this time rather than down, we can see we've got this pizza now chopped into 4 bits. Each bit, there you go, is a quarter. And we can see that I've got a quarter here, I've also got another quarter down here, and these two quarters, when I put them together, would be exactly the same size as a complete half. So what we can see is that 2 quarters would be exactly the same size as half. And this is what we mean by an equivalent fraction, because those two numbers on the screen, the blue one here, 2 quarters, and the red one, which is 1/2, are exactly the same size. Okay, if you're okay with decimals, you realise that decimal, both of those would have a value of 0.5. So they're the same numerical value, but just written with different numbers. And that's what we mean when we talk about equivalent fractions. Fractions that are the same size, but contain different numbers. If we go back to my pizza, and let's cut it in a slightly different way. So instead of going for quarters, I've put in 2 different cuts there. So now what I've done is chop the pizza into 6 equal bits. So each bit here, so each section that's kind of that triangular wedge shape, is 1/6. And now we can see that 1, 2, 3 of those, 3/6 make it 1/2. So we can say that 3/6 is equivalent to 1/2. And I could cut it in any number of different ways, and we could find all kinds of different fractions that were equivalent to 1/2. Now, if we're thinking about working with equivalent fractions, what we're going to do is say, well, if I want to try and find, let's say in this top example, 1/3 would be the same as how many sixths? So what I need to do is apply, there's a golden rule that we can use for fractions. That might be that you can spot it and just look at it and figure it out straight away, but there's a golden rule for equivalent fractions, and it's this. Basically what we're saying is, whatever you do to the top of the fraction, you've got to do to the bottom of the fraction. And there's a very good mathematical reason for why that works, but I won't bore you with the details just at the moment. But so let's have a look at what we're going to do with this top one here. So I'm going to say, well, 3 times by what is going to make 6? And clearly that's going to be times by 2. So what I've done effectively is times by 2 to turn a 3 into a 6. I've times by 2 on the bottom. So now I've got a times by 2 on the top. There we go. So 1 times 2 is 2. So 1/3 is equivalent to 2/6. Same principle on this next one now. I'm looking at saying, okay, 8 times by what is going to make 40? Well, 40 is on the 8 times table, and 8 times 5 makes 40. So I've times by 5 on the bottom to turn that into a 40. So I need to do exactly the same on the top. Times by 5, so now 1 times by the 5. So 1/8 is the same size as 5/40. And then the last one, we're going to turn a fraction that's 2/5. I'm going to turn it into 30ths. So we're going to find how many 30ths is exactly the same as 2/5. So imagine I split my pizza into 30 slices. So here we go. 5 times what is going to make 30? Well, clearly that's going to be 6. So that means I've got to do a times by 6 on the top. And now we've got 2 on the top here, times by 6. So that's going to turn that into a 12. So 2/5 is the same as 12/30. Okay, now it seems like a lot of hassle, but it turns out that using equivalent fractions is very, very useful, particularly for adding fractions, which you'll come to later on. But in this video, we're just going to look at how we can use fractions to kind of do some comparing. So here we go, another food-based question. So there's a big slab of chocolate cake. And clearly, yes, I would like some chocolate cake, thank you very much. But she's going to get all mathematical on me and say, well, would I rather have 1/3 of that cake or 3/10? Now, because I'm a big fan of chocolate cake, I'm going to want the bigger slice. So I'm going to need to work out, is 1/3 or 3/10 the bigger fraction of this rather fine looking chocolate cake? So here we go. Just by looking at the two fractions, it's difficult to tell which one's the biggest, and that's why having them with the same denominator, the same number on the bottom, makes life a whole lot easier. So we're going to do exactly the same as we did on the last slide, and we're going to do a bit of converting. Now, so we're going to say, okay, 1/3 is the same as how many tenths? So let's think, okay, we've got to do some multiplying, but here if you start thinking 3 times what is going to make 10? And that's a bit of a tricky question. And the reason is that 10's not a 3 times table. It's not an easy conversion to do. I'd have to start using decimals to be able to turn my 3 to times it by a decimal number to turn it into 10. So that makes life a little more difficult, but fear not, there is a fairly simple way around it. What we're going to do is find a completely new denominator. So we're going to replace the 10 and we're going to come up with a completely new number to use. So what we need, and we've got a hint down here saying what we need is a number that's on the 3 times table and on the 10 times table, because that makes our converting really simple. And can you think of a number that's on the 3 times table and the 10 times table? Well, the obvious answer, hopefully, that you're coming up with is 30. So what I'm going to do is take this off now, and I'm going to replace it and say, okay, it's equivalent to how many 30ths. Now let's go through the process again. So what are we timesing by? Clearly we times by 10 here. That means I've got to do a times by 10 here. 1 times 10 is 10. So there we go, 1/3 is the same as 10 30ths. So we know how big 1/3 is in 30ths. Now let's have a look at 3/10. So 3/10 is going to be the same as how many 30ths. So again, what are we going to times by? Clearly we're going to be timesing by 3. 10 times 3 is 30. Do a times by 3 in the same way on the top. This number here is going to become 9. So there we go, 3/10 is the same as 9 30ths. Now, just by looking at our two fractions as they were there, it's not easy to decide which one's bigger. But now we know that 1/3 is 10 30ths, 3/10 is 9 30ths. Clearly, this one over here is going to be the bigger one. So that's the amount of chocolate cake I'm going to want. I'd like 1/3. Thank you very much, because I can see now that 1/3, which is 10 30ths, is bigger than 3/10. Happy days. On we go. This is the kind of question that you might get on your 11 plus. It's a question for just putting numbers in order from smallest to biggest. So we've got to look at all those fractions, and we've got to get them all with the same number on the bottom, so we can then decide which one's the smallest, which one's next, and which one's the biggest. So first thing we need to do is decide on my denominator, my number on the bottom. So what I'm going to do is choose a 40 on the bottom, because 40 is on the 5 times table, it's on the 4 times table, the 10 times table. All of these numbers here at the bottom will turn easily into 40ths. So that makes my life quite nice and simple. So off we go again. Same process we've been doing before. We'll try and speed this up a little bit for you. 5 times, it's going to be 8, times by 8 on the top. That one is going to be 16 over 40. The next one, 17 over 40. It's already got a 40 on the bottom, and we already see that that one is going to be bigger than this one. We don't need to do any changing there. That one's fine. On to the next one, a quarter. What are we going to do times by? Going to be timesing by 10 on the bottom, and so times by 10 on the top. So that one's going to be 10 over 40. And when you're doing these, it is well worth spending the time writing them out, drawing in the arrows, and doing exactly the same process I'm doing here, because it really does help with your thinking. Because sometimes when you start kind of trying to do all things in your head, and you start saving numbers in your head, things get a little bit messed up. So it's easy just to draw in the arrows when you get in there. So as you start to get better with these, you might not need to, but to begin with, definitely draw in the arrows. Here we go with the next one. What am I timesing by? That's going to be a times by 4. 3 times 4. There we go. That's 12 over 40. And then the last one, 7 over 20. We times it by 2. So that's going to become 14. So now I can look at all my equivalent fractions. That one, that one, that one, that one, and that one. And say, okay, we can start deciding which one's the smallest, which one's the largest. Well, the smallest, if I have a look, is going to be here, 10 over 40. So my smallest is going to be a quarter. After that, where am I going here? 12 over 40 is the next one after that, is 3/10. Then we're going for 14 over 40, that's 7/20. Then 16 over 40, which is the 2/5. And finally, it's the 17 over the 40. That is the biggest. And there we go.